Hello, everyone, and welcome. This is Professor Bear with you here today to welcome you, first of all, to our Python 112 mini course. And let us go ahead and get started. So I've prepared some slides for you, which you can download from our Moodle page, which you are welcome to follow along with, or you can just watch the slides on here. So let me go ahead and share my screen with you. And let's get started. All right, so just to show you our Moodle page, you can go right onto our Moodle page, and you can scroll down to our mini section where you can find information about this course. So here is our 112 Intro to Computer Science mini course, which you should be able to see. Where you will find our syllabus for the course, our course calendar, and it's mini course. So I have included a schedule right here for your convenience for you. We have the lecture at 8:30 to 9:50 in the morning on Tuesdays, to be followed by office hours, and a problem solving session Thursday from 2 to 3:20, and that is also followed by some office hours. Now, since you are watching this video, I'm going to presume that perhaps you are going to be choosing to participate asynchronously, which is perfectly fine. I do hope that you would be able to make one or the other of these times at least, so I get to meet you and get to know you a little bit. But if not, please just feel free to reach out to me via email or whatever way is convenient for you to get in touch with me so that we can help you with the course and also just welcome you to Wesleyan. All right, so this is where you can go to get voluntary survey if you want to try to find some classmates who may be interested in working on your labs, and instead of working at the 2 to 3:20 time, like perhaps maybe there's several of you who are, I don't know, in the same time zone that's not on the East Coast of the United States, then you can use that. We also have a voluntary survey, and this is the Think Python textbook. We use this for the main course. It's not really necessary to read it for this one, but if you do want to get a head start, I have provided that there for you as your reference. Also notice that we have the lecture materials. So we'll be doing 2 lectures per day. So we have the lectures on Tuesday. So we'll do lecture 1, just this one right now. We'll take a little break and then we'll do lecture 2. You will have a problem set for each week. Now those can be done during our problem solving session time, and then you can post your solutions here. Now, do not panic, right? This is a mini course. This is for fun and for your information. So there is no grade. So what will happen if you don't turn in your problem set? Well, truth be told, nothing will happen, right? This should be fun. But if you do give me a problem set, I can take a look over it and give you some feedback, just to give you a sense of what it would be like to take the real course and just, see how things are working out for you, see if this feels like the right course. Maybe it's something you'd be interested in taking with me or with my colleagues this fall or at some other time. Also, you will be doing the problem solving, but of course, before we can do the problem solving, you need to install Python and just get up and started with working with Python. So for that, we have the Python installation guide and the Hello World available for you to get started with Python. Installation is pretty straightforward. Basically, you go to the website and download it and follow the installation instructions. But if you want a little more hands-on, you can use that. And Hello World, as it may sound, takes you through a few exercises in writing your very first script and working with Python interactively. And here we have the solutions to the questions that you'll be working on. So you can do those in our problem solving session on Thursday, but don't let me stop you from having a peek at those ahead of time. We also have the mini course program on programming and on functions, which we will cover in the week 2. Again, you'll have a problem set, and then you can turn those in. Incidentally, if you can please get those problems to me by the end of the problem solving session, that is when I usually do my grading, or for the purpose of this class, the comments to you. So just to make sure we have the opportunity to get those back to you so you can get some feedback, please have a look at those in a timely fashion. All right, so then with that, I think we will go ahead and get started with the slides. So let me put this out of the way and let us have a look over here at the slides. So like I said, feel free to follow along with your own slides or just follow along right with this. All right, and so this is a bird's eye view of today's lecture. We'll have an overview of the COMP112 course. We'll talk about both the full-length course, just in case I might entice you to sign up and take that, and also our mini course, which is what we'll be doing together over the next several weeks. Also, we will talk about the course components and grading, course policies, and a first look at programming. Again, this course is not graded, so no need to be worried about the grades. So let us talk about the 112 computer science course in case you might be interested in taking this. So the objectives of this course are to learn to think like a computer scientist. This may be your first experience with programming. We want to teach you how do we think about how to write programs. You're going to learn how to read, write, and reason about simple programs. Those are a number of the tasks that you would be doing if you were to become a computer scientist. Next, we want to learn the mechanics of Python. This is about actually the syntax of writing the programs and, you know, kind of the boarding stuff. Drills and those sorts of things are involved. So we learn how to do the programming. Next, it's important that we understand programs written by others. Oftentimes, if you work in a company setting, you will be starting with some code that has been written by somebody else, and you will be modifying and or expanding upon that. So it's important to understand what other people have written. We'll want to use programs to solve interesting problems. So in the real course, you will in fact do a project where you write your first program from start to finish. We'll learn how to break down problems into pieces that you can solve with the tools that we've taught you in the course, and also you may wish to synthesize solutions by combining the parts together from smaller solutions that you have made. That is known as modularization. This is where you can acquire the Python program. Just go to python.org, and this will take you to their website. You can then just click on the downloads button right here, and you can download the latest version of Python. Anything in the 3 point whatever will do just fine. You'll probably get version 3.8 right now. As of the time of this recording, it is perfectly fine to use 3 point anything. It is not fine to use an older version of Python, such as the Python 2s, which may come by default on your Macs, as it is a requirement for your operating system. So if you do have an older version, say you have 3.5, and that will be just fine. Otherwise, please just download the latest one. That is the safest thing to do. So who wrote this? Well, Guido van Rossum is the one who wrote it. His photograph is right up here. And we have a little bit of a cute and funny cartoon over here. And it says, it is a very full-bellied python saying, so who is this Guido van Rossum? He's not that important, right? Well, it's a good thing we already have his Python programming language. Just a joke, of course. His influence has been felt by many of the modern computer science programs that affect all of our lives. You're probably familiar with Google, obviously Python, and Dropbox. So Google and Dropbox are both users of Python, as are many other major corporations and other programs that you may be familiar with. That may even be why you decided you wanted to learn how to program. That's a very interesting biography. So if you do have the chance to look him up, I highly recommend having a peek at his background. All right, so who is the 112 full-length course recommended for? What is the course audience? Well, the prerequisite skills are basically that you have an essential understanding of working with computers. Now, for your generation, this is almost certainly by definition going to be guaranteed. But so what we're talking about here is, can you operate a laptop? Can you plug it in and turn it on? Can you use a Microsoft Office document? Do you know how to make a PowerPoint? Have you ever used Microsoft Excel before? Can you open a text document? If you can do any and or all of the above, then you are probably going to be just fine. We would expect you know how to open, edit, and save, say, like, for example, a text file. Aside from this, we do not expect any programming experience from you. You may be somebody who is in a bit of the gray area that has some programming experience, but perhaps you're not completely confident in your skills and would like to do a bit of review work. So this course may perhaps be for you. There is no prerequisite coursework for this class in particular. This course is appropriate for people who want to continue in computer science but do not have sufficient background for the 211 course. I will pause to point out that the 211-212 sequence is the gateway to the major. This course does not count towards the computer science major. However, if you are insufficiently prepared to start in the 211, then this is the place for you to be at. You may be interested in applying programming in the sciences, humanities, arts, and so on. You may wish to fulfill a quantitative general education requirement in NSM. This counts towards that. You may wish to fulfill a requirement for a variety of certificate programs. This does satisfy that. And also, you may wish to learn how to program specifically with the Python language in more depth than the QAC options. I would note that the QAC, or Quantitative Analysis Center, does offer a short version, a half semester Python course. And this one is a bit more in depth than you would get from that class. It could also be appropriate if you're somebody who programs in a different language and are interested in learning something specifically about Python. So just to give you a little bit of information, this course fulfills requirements for the biology, mathematics, and neuroscience and behavior majors. I will point out that it is not required for any of these majors specifically, but you can use it towards the electives that count towards that major, so you may choose to use it in that way. Also, for the minors, you can take it for the data analysis, education studies minor, and integrated design, engineering, and applied science, or ideas minors. These may be things that might be of interest to you, and I always encourage students to look at these, especially if you do tend to take a number of classes in this cluster, because you may already be well on your way to getting one of these minors, and might as well collect as many as possible. Same thing goes for the certificates, which are in many ways very similar to the minors. The certificate in applied data science, certificate in informatics and modeling, computational science and quantitative world modeling, and integrated genomic science are the two flavors, or the informatics modeling that you may wish to pursue, and the College of Integrative Sciences. Now, the textbook for the main course, and also being posted for this this mini course, is the Think Python, How to Think Like a Computer Scientist by Alan B. Downey. You can download the book for free as a PDF, or you can buy a hard copy at the R.J. Julia bookstore down on Main Street, Middletown, or at Amazon.com. Please do take note to use the second edition and not the first edition, because the first edition refers to a version of Python that is outdated and the syntax will not consistently work. Besides, it's free, so please just make sure you get the right one. We are using Python version 3, Alan Downey's second edition book. This is the link to download the PDF. So then on our Moodle website, you'll be able to find the syllabus, course calendar, homework, lab assignments, notices, and slides from the lecture. We had a look at the mini course one, and the one for the main course would be reasonably similar. The topics covered in the full-length course include algorithms, variables and statements, strings, if and while loops, functions, lists, dictionaries. Lists and dictionaries are some data forms that can be used in Python. We also have file input and output, which is reading and writing from an external file. And finally, we round things out using the object-oriented programming as our final topic. Again, the mini course is not graded, but the main course is graded typically along these lines. The course grade is comprised of 2 exams, so 2 midterm exams, roughly equally spaced throughout the semester, and they're each worth 25% of your grade. You would then also have a final project, which is equal to an exam in weight, where you would write a Python program from start to finish. We will meet several times throughout the semester to help you with your project. Also, in addition to that, you will have laboratory sessions and homework problem sets. So you would have 2 assignments each week. In the mini course, we are going to take it a little bit easier than that. You'll just have 1 set of questions to work each week. But the idea here is that in the full course, what you'll be doing is you will be practicing what we are talking about in the lectures during the lab sections. So you'll go into these breakout sections at various times throughout the week. So you'll each sign up for a particular section, and you would be in with approximately 20 classmates or so. And during those sessions, what you will do is you will work through some questions. The lab is based on participation. So as long as you show up and you do the work, you get 100%. But if you don't finish, you get 100% for effort. So if you have absolutely nothing to lose and every opportunity to ask a question or to get some help and just to explore some ideas and questions and whatnot along with your peers. So it is a really important component of the course, even though it is not worth all that many points. But oftentimes quite a lot of learning goes on during this time. And you'll notice that I may play devil's advocate in asking you some questions because I know which pitfalls you will encounter as you're learning how to program. So some of those things may become apparent as you work through the guide sheets so that I can guide you up and lead you to those things, and you will test them out and just be like, I didn't think it would work like that. And then you realize not to do that. And also, of course, just give you some drills to practice the skills that you learn in the course. And also just to practice with some problems, oftentimes related to things you'll do on your homework. In addition to that, you would get 1 homework problem set each week. So that would typically consist of around 5 questions for you to work. You may work with your classmates, but whatever answer you put down must be representative of your understanding of the material. So you would turn those in. So typically our schedule in the full length course, you do the lecture on Tuesday, you go to your lab. Most students will sign up on Thursday. I don't think we have any Wednesdays, but sometimes we have labs at alternate times. So you have labs typically on Thursday, and then then you would be working on your homework problems, and you would turn those in on the following Tuesday. So that's typically our cadence for the course. And this is me, the instructor. I am assistant professor of the practice in the College of Integrative Sciences. I teach a number of different courses here at Wesleyan University. Being an interdepartmental person, I do teach courses in a number of different areas. Truth be told, I do not have a degree in computer science. My degree is in computational chemistry, and so I am an applied computer programmer who works in the area of allosteric drug design. So sometimes you say, well, how come you are teaching my class? Well, it's because we oftentimes use programming on a regular basis to solve scientific problems. I also teach a course in scientific computing, where you can learn how to use Wesleyan University's high performance computing cluster and also learn about solving some problems using artificial intelligence and machine learning, some very exciting areas. I also teach, of course, the 112. I've also taught the Research Frontiers in Sciences. I've taught a number of chemistry courses over the years. I'm not slated to do that this semester in particular, but you may see me in that capacity. And I also have done the journal club for the molecular biology, the biophysics program. So you may see me cropping up in a variety of different places. A couple of fun facts about me. I'm a graduate of Wesleyan University. I went to graduate school here. I rescued 2 greyhounds so far. And you may see me on campus walking my dogs. Unfortunately, Priscilla is no longer with us. She's gone over the Rainbow Bridge as of a few months past, but we still have Mr. Max with us, and this is us walking just across the street from the fire station. So if you do see us on campus, Max is a friendly kind of guy who enjoys getting petted, so you can come over and pet him. I also have quite a few pet fish, and additionally, I may be collecting some mantises as well. So we have an awful lot of pets. All right, so I'll be inviting you to share a few fun facts about yourself. If you wish to fill out the survey, which I have also provided for you on the page. It's always interesting and exciting for me to learn about interesting ways we can connect in addition to what we learn about in the class. All right, so then specifically about the mini course, this is basically a subset of what we do in the main course. We will have a series of 4 lectures, algorithms, variables, statements, and functions, which will give you a taste for what the content looks like in the real course. This is how you can complete the course. You have several options. So the lectures you can listen live on Tuesdays beginning at 8:30 a.m. Eastern Daylight Time. We do both lectures back to back with a short break in between. So for example, we'll be covering lectures 1 and 2 on the first day, that is today. And then we would be covering the numbers 3 and 4 in week 2. So I do hope you can join us live, but if you're listening to this recording, then probably you can't. So anyways, that's what the rest of the class will be doing, and I do hope you'll be able to join us at some other time and to be involved in the class in whatever capacity you can. However, we do have these recordings for you to work asynchronously, or perhaps maybe you just want to review it or go back to it at some later time. So we have these available for you. Also, we have the problem set, so I hope you will join us for the problem solving on Thursday at 2 p.m. Eastern Daylight Time. I picked that time because it's representative of what you might have for a lab time. So oftentimes you will go to lecture on Tuesday mornings, and then you have a lab either Thursday mornings or afternoons, because we break you into some smaller sections. You should sign up for a problem solving group. You could work and do that separately if you wish to join us at another time. Otherwise, if you're going to join us at 2 o'clock, you can just work with us. You could also complete the assignment independently if that is something that you would prefer to do. Just as a note, I would really appreciate it if you can post your solutions promptly at the end of the problem solving session on Thursday. So that will be 2 to 3:20, just so that I can get you some feedback in a reasonable time frame. So when we do the real sections, I really do strive to get the comments back on the day of your lab. So by Thursday evening, Friday morning, so that you'll have that to use for doing your homework. So in this case, we don't have a separate homework assignment for you to do, but I think it is useful to get some feedback, and that is the purpose of having those deadlines. So this is just to review the schedule. We actually saw this when we took a peek at the course earlier. So Tuesday, 8:30 to 9:50 lectures. I'll stay after for office hours. Office hours are optional, but I'm always happy to chat with you about the course or about coming to Wesleyan, being a WestMass student, labs, research, whatever else might be on your mind. Thursdays, we have lab from 2 p.m. to 3:20, so we'll be working on the problem solving. You can go into breakout rooms with a small group of your peers and chat about how to solve the problems, and I'll be coming around to help you on those, and we will reconvene and talk about how to solve the problems. Furthermore, I will also stay after on Thursday from 3:20 to 4:30 to answer your questions, and so if nobody's there, I'll just get started on sending out your comments. Otherwise, you are free to stop in up until 4:30, and I'll just leave the Zoom on so you can either drop in or just hang around after the lab so that you can let me know what's on your mind. Okay, yeah, you don't need to get them in by 2 since we're starting at 2. I should just get them in when you're done with your problem solving session, which would be 3:20. Please post them so that I can get you some comments. Again, for feedback only, please do not panic about grades. All right, so then let us take a first look at programming. This is a sample function written by a Python student from a previous year. This is from an actual final project, so the culmination of the class. Now, I bet you can already start to understand some of the things that are happening in here. So we take a look here and we start to look at some of the clues. All right, it looks like something's being printed to the screen. It says, "Welcome to a Monster Ball shop." It was part of the students' choose your own adventure game. How can I help you? Okay, now we have this while true loop, you see, so this will be continuing until a certain condition is met. So here we are going to print out how much money the player has. And this is a variable called do is equal to whatever answer they choose. Buy a monster ball or leave the shop. So they should type 1 or 2, but you know, not everybody's as smart as you. And so we're gonna need to take care of the contingencies, what to do in the various situations. All right, so if they want to buy a monster ball, we'll need to decide if they have enough money or not. And so this will provide some information on that, considering whether or not it is less, the user has less than the cost. So sorry, you don't have enough money, or then you just bought a monster ball. However, they could also choose option 2, which is to leave the shop, and then it thanks the user for coming here. And otherwise, we will get into this else statement, which implores the user, please pick one of the valid options, 1 or 2. So this just gives you a sense of what's going on here. Of course, I wouldn't expect you to understand all of the syntax here or all of what's going on, but certainly you can probably already get a reasonable sense of what's supposed to happen. Why should you learn how to program? Well, you may want to interact with your computer on your own terms, automate repetitive and/or laborious tasks, bring your ideas to life. Computers can also do certain tasks much faster than humans, which is one of the reasons why I use computers in my drug design applications. And how about you? Why do you want to learn how to program? The reasons to want to learn how to program are as numerous as the students who sign up for the class. So in imperative language, programming languages, there will be a set of instructions for the computer. However, this is not the only way that computer programs could be written. So there could be multiple ways that these things could be approached. In addition to, well, so what we'll say is that in computer programming, if you're thinking about computer programming, imperative programming is almost certainly the kind of programming that you've already been thinking about. And this kind, we would have a set of rules, algorithms to follow that are the steps in order to get to whatever task is trying to be done. And it is the programming language that allows us to communicate the algorithms to computer so that it actually knows to compute the answer. So some examples of imperative programming languages include Python, which you're learning now, any of the C languages, Fortran, which is a rather old but still incredibly fast and useful programming language for scientific purposes, the BASIC language, and some aspects of MATLAB. There are other types of programming, such as declarative. In this case, what one would do is tell the computer what you want to happen, and the computer figures out what to do. This is the kind of programming that is used in machine learning, and it is not covered in this class. We're going to do imperative programming with Python programming language. So then let us think about algorithms. Algorithms really are simply just a set of instructions in order to get to a desired result. Here we're considering a pictorial view of Euclid's GCD algorithm. This is for calculating the greatest common divisor, or the largest integer number that goes into some other number without a remainder. This flowchart is going to take you through the steps on how to do that. Now, this may not be necessarily the way that you learned how to compute the GCD. However, I definitely encourage you to step through these one at a time to figure out how it works. So for example, we would just follow the little diagram to see what steps it wants you to do. So we begin at the top, and we ask if b is equal to 0, true or false. So if the answer is yes, it's true, then we print a, but otherwise we would do no, and then we compare a and b. So a and b are going to be the two numbers, right? So if no, then b gets the value of b minus a. So that indicates that b would be overwritten by the answer to the problem of the current value of b minus a. Then we would go to 2. So we go back up here. Otherwise, if we had answered yes, then we would do a gets the value of a minus b and go to 2 and redo the evaluation of whether b is equal to 0. And finally, b will be equal to 0, and a will be, in fact, our GCD. So it may be a little puzzling too whether or not it works, but I definitely encourage you to think about this and to test it out for 2 numbers to see if it in fact works, which it does. So let us also talk about parsing syntax. So the idea with parsing syntax is extracting the meaning. Now, perhaps you've taken some English classes or some kind of a literature class where you read a quote and you may be asked to consider what the meaning of it is to you. So here I have included a quote from the book To Kill a Mockingbird by Harper Lee. And this is a quote from Atticus Finch, one of the characters in that book. So one thing we might do is ask, well, what is the meaning? What is the meaning of this quote? And we would need to perhaps not look at it a single word at a time, right? But you might consider the greater meaning that all of those words put together conveys. That is the beauty of language, that we are able to put together some of the smaller individual words and to create some idea. And so what we're going to need to do with parsing syntax in a computer programming language is to extract the meaning of the symbols into instructions for the computer to carry out. So an example from mathematics, we might think about the order of operations. Maybe you've seen, please excuse my dear Aunt Sally, the order of operations mnemonic, parentheses, exponents, multiplication and division, left to right, addition and subtraction, left to right. Those are the typical rules that one would follow. So we may say, parse the following mathematical expression and then evaluate this. So if we simply just move from left to right, rather than extracting the meaning of this, we might naively add 1 plus 2 first and multiply that by 3. But of course, that is not the meaning of this expression in terms of standard mathematical rules. So then we would need to do the parsing, that is to extract the meaning by applying the parentheses to the multiplication, which takes precedence, and then evaluating this expression, which would then instead give us 7 rather than 3 times 3, which would give us a result of 9. So then in today's lecture, we have covered an introduction to imperative program. We have taken a brief look at algorithms. We have talked about syntax, and we have also talked about how to parse syntax. We'll see more of these topics in the upcoming lectures, but I hope you've enjoyed the introduction we've had today and also enjoyed hearing a little bit about COMP112, the full version, and also seeing how we will complete the mini course. So thank you so much for joining us. I hope that you will come back and see us next time for lecture number 2. Thanks so much.